Welcome. Today we're going to talk about how to put this machine into the Fusion library so that it will simulate your parts as if it's in the machine. And specifically, we're going to address how we add the OTS, the base, and the vise, and make the vise dynamic so you can set a number for how big the stock is to open and close, and have that all work so when it simulates, it looks like it's running in the machine. Stick around. It's going to be fantastic. Okay, to get started, we are going to take a few measurements. We need to know where the base is on the table as well as the OTS. I've measured from the right-hand side over. The base is 10.5 inches, and the OTS from the right side to the center line is 7 13/16. So in Fusion, we're going to have to use that 10.5 to place the base plate and that 7 13/16 to place the OTS. But before we can do that, we need to collect all of this peripherals and the machine and get them saved onto your Fusion documents. So let's go ahead and get started with that. Okay, for those of you that are my students, you will have access to this LHS machine tool library, which is where I have all of the components for our machine shop stored. For those of you out in the World Wide Web, you're going to have to go to websites like GrabCAD, Haas, or even Fusion has the machines, at least some of the machines downloadable for you, which I'll cover briefly. So let's go ahead and get started. So those are my students. What you're going to do is you need to copy all of these onto your own. You only have readable versions here, so you're going to have to make a copy, and it's quite simple. You're going to right-click and say copy. And this is our mini mill, and then I made this miscellaneous folder, and I'm going to create a new folder to store all my machine tool parts in, and I'm going to call it machine tool library, and then enter, and then I'm going to open that up, and I'm going to go ahead and make a copy of the Haas mini mill to that location. And then we're going to need some work holding stuff. So we're going to need a base plate, and on our mini mill it's this one right here. So we're going to go ahead and do copy again, and we're going to put it down there as well. And then we're also going to need, for this one, we're going to need from the peripherals, we're going to need the OTS. So go ahead and hit copy. And I'm going to go down here again and save it here. And then last thing we're going to need is we're going to need a vise, which is also under work holding and vices. And for this one, we're going to use this standard 5th axis vise that I'm providing. Copy. And down to miscellaneous and copy it there. So now we're going to go into our copies and go ahead and open this up. And the first step is we're going to build this machine. So we're going to go ahead and load the mini mill. And to make our lives a little bit easier, our first step is going to be we're going to turn off statics, which is basically take off all the sheet metal. Now we can see the table. It does exist. It's in the background, so don't worry about it. The other thing to note is this is all in metric. Haas clearly designs metric. Most engineers do. I had an imperial tape measure. But that isn't going to be a big problem, as I'll show you here how we can convert quickly. So I'm going to start with the base plate, and I'm going to go ahead and say insert into current design, and in it'll come. It's obviously not in the right location. One problem with these base plates is they are not a rigid group. So I'm going to go ahead and make this a rigid group. I don't need all these subcomponents to move for this part of the function, so right-click, create a rigid group of that, and click yes and OK, and now this is a rigid group. Now I know that the grooves here are 20 millimeters wide, so the center of the table would be 10 millimeters from one of these corners. So I am going to assemble this just like I would assemble any other project in Fusion. So I can go to assembly and joint. Notice it's a hotkey J. So I'm going to come and I'm going to pick the center of this. If I hold down control, I'll stay on the bottom. Now when it first moves, I'm going to move it to here, All the subcomponents don't come, but they'll follow in a minute. I'm going to drag this the direction I want and type in -10. So now it's in the center. And then I'm going to drag it in the direction I want and go -10.5 IN. And that will give me the inches, which comes out to 266.7. And press enter. And then all the other components came. So there's our base plate. I'm going to repeat the process with the OTS. So same thing. This one is a single piece, so it doesn't need to be rigid grouped. So we're going to go ahead and go J on the keyboard for join, and I'm going to select the bottom of this. And I'm going to select it's on this back T slot. I'm going to rotate it 90 degrees, which is where ours is. And I'm going to slide it to -7 space 13/16 space inch. And it will then place it where it goes on our table. And there we go. Last thing we have to do is we have to put in the vise. Now, I'm going to go ahead and open this vise to show you how it works. So I have dynamically put this vise together, meaning that I can go into this function key. If you don't have that function key, it's found under modify near the bottom. And you notice I can establish how wide I want the vise to be open. And in my case, the stock size is 2. And if I press enter and click OK, the vise should be open to 2 inches. And I can check that by picking this surface and this surface. Oh, and it's 2.2. That's correct. Oh, I forgot. The vise jaws are 2.2, but the offset between the dovetails in here is 0.1. So we're going to go ahead and modify this because we're going to be putting it on the dovetail to 1.8 and click OK. So we have that. That's how the device works. I'm going to save where we are, and I'm going to go ahead and close this. And then I can go ahead and right click after it's done thinking. Right click, insert the current design. And there's my vise. And I'm going to click OK. Notice the origin is viewable. I'm going to go ahead and turn that off to make our lives a little bit easier. And then I'm going to go J on the keyboard. And the easiest way to actually install this vise is this hole in the center is the same as the center of this base plate right there. And I don't have to line up all the holes. And I should click OK. And in this case, it will come across. We have a rogue. If I click on it, it'll tell me which one it's on. So it's construction. So now it's gone. But now, if I want to change the vice's size at this point, I can open the mini mill and I can click on the pencil here, and it's going to allow me to go in and I can edit the function. So let's just make it 3 so you can see a major change. But it's not going to change until I hit finish. Notice it opened up to 3. Obviously, I don't want that, so I'm going to go back and hit finish, and oops, I have to go back twice. There we go. Now we're back to the 2, which is what we're going to use for this simulation. So we now have the table all put together as planned, but our problem will be if we simulate it at this point, these parts will not move with the table. They're not attached in the machine library component. So what we're going to now have to do is switch to manufacturing. Click on machine library. So I've made an LHS library by going to cloud and hitting add a folder. And then here I have the option of hitting add a tool. I can also search Fusion's extensive library and import one in, which is the way you could do it with the mini mill. I give you the files. It's easier and less likely for you to make a mistake. But if you are from the World Wide Web, you might want to go this route. But what I'm going to do is I'm going to go back to my library and I'm going to import a machine. And in our case, it's going to be this mini mill, and I'm going to hit select. And it's now imported that into the library. But we need to do some modifications. So we're going to right click and say edit machine builder. And we're going to come to this window. And our big problem here is the table will move dynamically with the machine, but our peripherals on top will not, vise and whatnot. So what we have to actually do is go to machine setup, and under X, because all of these are attached to the X to the table, we go ahead and click on X, and we need to add this, and click OK. Now they are attached. We're going to edit the machine builder again. And we're going to get back here and we're going to go ahead and hit close. Now we happen to already have it open, so it's still open. We are now done with this and we can hit save. Okay, we're now going to use our machine tool library to manufacture this part. So to do that, the first step is we got to move to manufacturing. Yours shouldn't have the yellow arrow because I did this then deleted it. So the next thing we're going to do is do a setup. And the very first thing we're going to do is select machine. We're going to pick on the machine that we've created in our library and hit select. And you're going to notice when we come back in here, we now have 4 tabs as opposed to the original 3. We would then go through this process. Ours happens to come in the way we want it as far as where the origin is and the world coordinate system arrows pointing the proper direction. So we're going to go to second tab. We are going to change the stock size always to fix, and we are going to offset it from the top 0.02, which is a standard thing I do in all my classes. And then under position, you're going to notice that the block comes in and the machine not in the right spot. So we're just going to manually move it. And the easiest way I find is to start with moving it to the right. And we can move it into the jaws like so. And then we can zoom in and we can notice that it's off a little bit. So probably 0.9525 maybe. That looks about right. And then we can turn it 90 degrees and make sure that it matches in the center of the jaws. Because we're ultimately going to probe these parts using the probes in the Haas machines, we don't need to align it perfectly. Just an eyeball in the center is going to work. The main reason we're doing this is to ensure that the cutter doesn't actually collide with the vise. And then we would go to our last step, and this would be 2.1111, and we would call this OP1 cam 1.1. And our work offset is always, in this class is not G54, it's probably G55. And we would go ahead and click OK, and you'll notice now that the machine is placed. And I could go ahead and do all my programming, and then it would run like a simulation. But what happens if we already created a cammed part before we did the machine? So here's a part we've created, and we did all of this before we machined it. So we're going to start with op1, and we're going to go ahead and hit edit, and we can now select machine and choose this. Once again, this tab is going to come up, and I can go here, and then I can move it up. I always like to start on the right to get it in the right position. Zoom in. My guess is it's going to be 9.1. Nope. This one's going to be 8.925. Looks pretty close. Turn it 90 degrees. And then slide this over once again to get it in the center and click OK. And we can now go ahead, and now that we have it, if this blue arrow appears, we may need to update machine. And there the machine is now updated, and we can go ahead and go simulate with machine. There we go. It says there's 5 warnings but no errors, so we can go ahead, and if we want to turn off the base, we can click here to get a better view, or we can see it in the machine, or we can make the machine transparent. We could also make the machine transparent without the base, and we can go ahead and hit play, and we can watch the cutter go, and we can also zoom in and look directly at the front and see, oh, okay, it's really close to those jaws, but it isn't hitting them. And there's our part, and then we should be able to zoom in like on the right, and we can see that there is a very small gap between the top of the jaw and the bottom of the cutter. And this is why we use machine simulation in Fusion when programming with CAM. Thanks for watching. Hope you learned something. Hit like and subscribe, and I'll catch you in the next one.